Insects, which make up more than half of the world's species, are disappearing at an alarming rate, raising fears of insect extinction. Of the world's nearly 10 million insects, around a tenth are classified.
We are talking a lot about decline of insect diversity in the world, but then the majority of information comes from Europe and North America. We know little about what's happening in the tropical area. So we really need to build the basic understanding of the distribution of insects.
In the rainforests of Yunnan province, China, there is a botanical garden that attracts experts and scholars from all over the world. One of their goals is to prevent a mass extinction of insects.
In other parts of the world, we travel long distance, then bring the samples back to their research institute, which can be very far. One of the beauty, advantage of XTBG is that it's not actually close proximity in the rainforest. And we have a lot of cutting-edge facilities.
Researchers from around the world hope to join forces to identify the causes of insect extinction by studying the relationship between insects and their environment.
You see any?
Tree holes provide a starting point for investigating this relationship between insects and their environment.
Everyone needs water. Insects need water. They need aquatic habitat to develop, to complete their life cycle. This little hole creates the whole ecosystem. This is their universe, really, little universe, right? And then you can actually sample the whole thing. So that's why we found this tree hole community very useful.
You need a pH meter.
The more information that can be gathered about insect tree hole communities in different environments, the clearer the complex relationships between insects and their environment will become.
Okay, let's go.
Oh, there's no water in that. No, it's too small. No tree hole.
However, tree holes are randomly distributed, and there is no water in the dry season. In order to divide the vast rainforest into small universes that can be studied, the first thing researchers need to do is to create artificially simulated tree holes. In order to simulate a variety of forest environments, it is necessary to choose containers of suitable materials and sizes.
I think this one may be the best choice.
In addition, insects will only make their homes in the artificial tree holes if they are almost identical in colour to the real holes.
Hi Akius, it's great to meeting you. And
Preventing insect extinction is a global issue, and scientists all over the world are participating in research.
So we have already more than 80 partners, and most of them already set up the experiment at the global scale. But what we are still a little bit missing is also the vertical stratification. It's also great that you have a canopy crane there in China for our global experiment.
That'd be great,
The forest canopy, described as a virgin environment, contains a large number of unknown insects. However, since the tree species in the tropical rainforest are generally tall, the canopy is inaccessible. Placing a tree hole at a vertical high point requires an 80-metre climb, a near impossible task. Xishuangmanna Tropical Botanical Garden has the world's highest 80-metre forest crane. This enables researchers there to reach the virgin land of the forest canopy.
Welcome to the tallest crane in the forest. 72 meters now.
I like you so much.
Ada, this is fine to around here.
These tree holes, placed in an 80-metre canopy, will collect unique and important samples for the global experiment. The scientists performed DNA tests on the samples they collected and found that the rain had altered the structure of nutrients in the canopy tree holes, suggesting that irregular precipitation can prevent canopy insects from finding suitable habitats.
Too much or too little rain can homogenize communities, and this is increasing every year.
The global treehole experiment is continuing, with more and more data being shared between researchers worldwide, giving scientists new hope for preventing insect extinction.
But by understanding this small universe, we can actually apply our understanding of this small planet to the bigger planet, which is Earth.